Howdy, this is your friendly neighborhood physics teacher here, and we are going to talk about the air track demo. So this one's going to be a little bit different because I'm going to have to hold and do it at the same time. We'll see if this works. So your air track, see if you can see it. So your air track, so at the end of your air track, you have a spring. There it is. Okay. Then you have a spring. And so that's when the cart goes and hits, it'll hit and it'll compress back. So it does have a spring. And the air track, remember, does release air, so you don't have to worry about friction on the track itself, but you'll still have friction here. And then you have your cart all the way up here. I'm going to see if I can shoot it so you can see it move kind of down the track. It's about to get really, really loud, just giving you all a heads up. It's about to get really, really loud. Okay, so that's the movement of the air track. So now let's talk about what's happening at each little spot. So you can kind of visualize it. I'm going to disappear so I can write. Maybe, there we go. So now, let's think about what's happening on the air track. Well, first, our track is on an incline. Now, it's not that crazy of an incline, but it is on an incline. And we have our cart up here. And we do have the spring down here. So up here, before it starts moving, hopefully you know that it has gravitational and it'll be max gravitational. As it starts moving, that gravitational energy is getting converted into kinetic energy. Right before that cart hits the spring, so right before that cart hits the spring, it's going to have max kinetic energy. Now, when the cart does hit the spring, it's going to take that max kinetic energy and it's going to add elastic to it. It is going to add elastic because the spring is being scrunched, but we're also taking away work due to friction because you heard it made a sound. There's a little bit of thermal, so we are having, because it does come in contact pretty hard, we do have that loss of energy. So again, from here to here, it's going to be considered a closed system. It doesn't become an open system until it hits, and that's what causes it to be an open system. So we would have our gravitational max, which would equal our gravitational plus our kinetic, which that would equal our kinetic max, again, right before it hits. But then we'd have to take our kinetic max and add our elastic potential, but we are taking away from work. And so this would automatically be greater than that. And this kind of repeats itself. So you take what we have, we take our kinetic max plus the gravitational potential, elastic potential, minus our work, and that would end up equaling whatever kinetic energy it is right before, like right after it leaves. And then that will end up equaling your kinetic energy getting converted into your gravitational. And then that would end up equaling whatever the gravitational it is. So that's why, again, it doesn't get to max height because it loses that work along the way. That's why each time it's getting shorter and shorter and shorter. So that would be your equation. And then you can sit there and explain what's happening a little bit more in your work. Hopefully that helps. Have a wonderful day. Remember, you're loved and appreciated. Bye.